Hello and good afternoon, and welcome to this video tutorial on BGP AS Path Prepending. Now this is going to build on my previous video tutorial, which was the CCNP ROUTEv7 BGP tutorial, in which we talked about the multi-exit discriminator, the MED value, in order to influence the incoming flow of traffic into our enterprise. We also took a look at the default originate statement, where we had the ISP propagate a BGP advertisement down to both of its peers, router 6 and router 7, and also we call them aka Santa Rosa 01 and Santa Rosa 02. And we also dug a little bit into creating some route maps. We took a look at the different address family configurations for IPv4, or for BGP IPv4, and also for EIGRP, but just on the inside, and that was rather quick just to get us set up for our iBGP peering. So we actually, the routers are in the exact same state they were when the tutorial yesterday finished, and so let's go ahead and take a look here on ISP. And when we wrapped up yesterday, the last thing that we had set was the MED. So I'll say do show BGP IPv4 unicast, which is sort of the new school way to run the command show IPBGP. Because again, when you're dealing with address families, or if you're using IPv6, you're using address families, the show IPBGP is going to give you the IPv4 information. To see that IPv6 information, I would want to say show BGP IPv6 unicast. And there is no IPv6 yet, so that's why it's blank. But again, let's take a look here, and we can see, if we remember from yesterday, we have the asterisk, which indicates that this is a valid route, the greater than sign indicating that it's the best route. Now there is a gap here because this has been learned externally from an external source, right? Because the 172.16 has been picked up from Autonomous System 64555, which is our company down here. And we're basically, the use case here is we've got company A, and company A is multi-homed to the same service provider router. All right, or to the same service provider for that matter. We then have the network, so we're learning about the 172.16.00 and the next hop, and we're influencing this with a route map, right? Because again, it's very easy to control the outbound flow of traffic, and we did that yesterday with the local preference. We created a route map, and we were able to do some layer 3 traffic engineering with BGP using the local preference path attribute, and by manipulating that. And that was for our outbound traffic. Now we wanted to control the inbound traffic. So traffic that had exited the network, we're trying to control how that's going to come back into the network, and we use the MED. And it's important to note that the MED, right, the multi-exit discriminator, is an optional and non-transitive path attribute. And so what does that mean? Well, optional means that it does not have to be supported by all of the BGP software releases that are out there. So HP may or may not support it, the Juno S, Arista, so forth and so on. And non-transitive means that it's not passed, it's local, so it's not transitive, it's not passed along from AS to AS to AS to AS. So in this case, when we take a look here, we were able to manipulate the metric, or the MED, and we set it to 50, right? And we're going to take a look real quickly at where we set these to. And so this is influencing the return traffic, because if you remember at the beginning of this exercise 7-3 yesterday, what we saw was that by default the traffic wanted to go back through Santa Rosa 02. That was where our inbound traffic from the service provider, the internet out here, was coming back in through router 2. However, we've now been able to manipulate that, and the lower the metric, the more preferable the route. And so the metric of 0, this is set by default. So if there is no value set by default, it would end up getting set to 0. And you can see here that 75 is less preferable than 50, and that is why the prefix that has the med of 50 is the valid and best. All right, so let's clear the screen here. We're going to take a quick look over on router 6 and router 7. We'll take a look at router 6 first, which is Santa Rosa 01. And we'll say show run and then section BGP. And this is going to give us our BGP config. And now on router Santa Rosa 01, we're running the 15.3 code. And I can go into the address family format. You can see here I've got my IPv4 address family configured. Right, so this looks a little different than the default BGP configuration section. And we'll see what that looks like on router Santa Rosa 02, which I've left at 12.4.24 T2 code. And here is our neighbor statement that references the route map primary underscore med. So if I was to say show route map and hit enter, you can see here's the route map primary underscore med. Again, very, very straightforward route map. We're basically just making it a permit, sequence number 10, and the clause is basically setting the metric to 50. And so we apply that in the outbound direction, because remember, we're trying to influence our neighbor upstream here. So when we set that outbound, we're trying to influence this ISP router with the med value, right? And so that's why it's set outbound. When we were setting the local preference, you'll notice that the local preference, which where we call that primary T1, secondary T1, that was set inbound, right? So the local preference was set inbound because we were applying that to the prefixes. We were applying this path attribute to the prefixes that we've picked up from the ISP. And then that information gets shared between the iBGP peers. And that's how we controlled the outbound flow of traffic. Again, the outbound flow of traffic being manipulated by using the local preference. Okay, so let's go ahead and clear this layer out here real quick. We'll come over here, and so let's take one quick look at router 7's BGP config. And we're just, or I'm sorry, router 7 Santa Rosa 02. We're going to say show run section BGP. All right, and so that's what the BGP section looks like. Again, much different, right? No address family. As you can see up here, we've got the address family IPv4. We don't have it here, not supported on this version of the 12.4 code. All right, so we use the med, and it's okay to use the med. However, there are some challenges with the med. One of the first is, again, it's optional and non-transitive. So it may or may not be supported. You may run into issues. When you multi-home to two different service providers, you may end up having some challenges as well, where you end up using BGP always compare med to force the evaluation of med, and then along with that you would want to use BGP deterministic med, because by default prefixes are evaluated in the order that they're received. So for whatever reason it comes in and it's a little quirky. So what this video is going to talk about is AS path prepending, which is probably the more suitable approach to dealing with the traffic, the layer 3 traffic engineering in an ingress fashion, right? So we're trying to influence the ingress traffic coming from the service provider. And the reason that AS path prepending is a little more robust of a solution is that it is a mandatory well-known attribute. So along with the origin and the next hop, AS path is a mandatory well-known attribute, which means it must be supported in BGP implementations. So your odds of running into issues somewhere along the line where the med, for whatever reason, doesn't function properly, you shouldn't run into those issues with AS path prepending, because again, the AS path, it's a mandatory, well-known BGP attribute. So let's go ahead now and we're going to create, we're going to do some AS path prepending. And before we go there, remember we took a look yesterday, I don't believe I still have it available, but we took a look yesterday at the decision-making process and the AS path along that the weight, which is the Cisco proprietary, is number 1, and then it sort of steps down. Well, number 4 is AS path, right? And so if I'm on the ISP router, and again, remember, we're trying to influence how the ISP router sees our routes. So I'm going to say show BGP IPv4 unicast. And again, so here is the path as learned by the ISP. As you can see, it sees our autonomous system number here. So this is the autonomous system from which this originated, and it's the only autonomous system through which this prefix passed. And that's us right here, 64555. And that is how the ISP learned about the 172.16.00 prefix. Now, with the MED, right, the MED is actually compared after the AS path. So we're going to go ahead and prepend our autonomous system number to the prefix on router 6 and router 7. And we're going to do it, we're going to put more instances of the prepended AS on router 7, or actually, let's see, we can go ahead and flip this. So we'll put more instances of the AS number in on the prefix for router 6 in the route map for router 6 than we do on router 7. And what we can do is we're going to influence the inbound flow so that the ISP sees fewer AS path entries for Santa Rosa 02. And so let me go ahead and draw that up here real quick. So what we're basically saying is we're going to create a route map, and I'm going to do a prepend, and I'll prepend, we'll put 3 here. I'll do 64555, 64555, 64555. So we'll add 3 additional AS numbers here. But here I'm going to add 5. And so what will happen is, remember, the BGP path selection criteria, it works down that list that we looked at the other day, and ultimately, when it gets to the 4th criteria, because the first 3 they're all going to be pushes, right? They're going to be equal. It's going to get down to the 4th criteria, which is the AS path, and it simply takes a look at each path that it has for the prefix in question and says which path has fewer autonomous systems listed. So simply by prepending our AS path, and actually that's a very important point, I want to say you must, but you definitely want to use your autonomous system number, because again, I'm trying to influence traffic coming back to me, so I wouldn't put 50, 60, 70, 80, right? Because first off, these are not my autonomous system numbers, right? So I'm going to want to make sure that I have my autonomous system number listed there, and all I need to do is prepend more instances of my autonomous system number to the path that I do not want to prefer. And so therefore I could, I could leave this with 0, but I'll put additionals in here, and I think the code may even remove them and just leave it as a single, right? But we'll see. So let's go ahead and jump in here with the, give me 2 seconds, clear that. All right, so that's what the ISP sees right now. My valid and best and preferred path, because of the metric setting, is through Santa Rosa 01. All right, well, let's jump on to Santa Rosa 01, and also something that's interesting that I've noticed is the 15 code. When I make these changes, it updates extremely quick, whereas with the 12.4 code on router 7, it forces me to actually do a soft reset. So let's go ahead here and get onto router 7, Santa Rosa 02, and I'll do a do show run section BGP. And as you can see, this is sort of the old school configuration. Here's my outbound med statement, and this is what's setting the med to 75, making it less preferable. But what we're going to do now is, again, sort of a more scalable and even more realistic scenario where we're going to do AS path prepending. So the first thing I'm going to do is I'm simply going to create a route map. So we're going to say route map, and I'm going to say AS prepend 64555 and permit 10. And again, we're applying this to everything, right? If I wanted to start trying to break it down as to, well, this prefix I want coming in this way, this prefix I want coming in this way, we would then have to start taking a look at prefix lists and incorporate those into our route map. But what we're doing here is we're just saying universally, I want all inbound traffic to go one direction for this AS. So I'm going to go ahead and set AS. Let me make sure I get this right here. And yeah, AS path, there we go. Set AS path prepend. And now what am I going to do? I'm going to go ahead and I'm going to put in the AS number, right? So I'm going to say 64555, 64555, 64555. So I'm going to add, and we'll actually go 64555. So I'm going to prepend the autonomous system number to the prefix, right, that ISP is going to see, or all the prefixes that the ISP is going to see from me, right? So I've added that in there. So if I say do show route map, we can take a look here. We've got a couple, and where is my AS prepend? So here it is right here. And you can see it's just prepending to the AS path. Now, I need to tell the router to apply this in the outbound direction because I'm signaling, right? I want to signal the ISP, hey, I'm prepending, we need to prepend this AS number this many times, 4 times, to the entry that you already have. So let's jump into the router BGP 64555 config, and I'm simply going to say neighbor 192.168.1.1, and this is just like we did the other day with the local preference and med settings. It's just simply neighbor 192.168.1.1 route map, and then the name of my route map, which is, where's that here? I can cut and paste. AS prepend 64555. Right now, the key, do I apply this to incoming routes, or do I want this to map this to the outbound routes? I want this to be mapped to outbound routes that are going to be going up to that ISP router. So we're going to call out and say that this is outbound. That's where we want it applied. So I'm going to hit enter. And what's interesting is I'll come over here, and I'm hoping this cooperates with me here. So you'll notice I'm hitting enter, and we don't see anything. With respect to what I should see is a longer list of AS paths listed with this route here via Santa Rosa 02. And I don't see that yet, right? And this is what I was commenting on. The 12.4 code, it actually has forced me multiple times, or every time I should say, to do a soft reconfiguration outbound. Then I'm able to see the values, right? And I'm not sure if it's the BGP scheduler or that I'm not being patient enough, but with the 15.3 code, when I make that same change, when we create the route map and I go in and apply that in the outbound direction on Santa Rosa 01, the 15.3 code is extremely fast in terms of making the update. So there we go. Okay, good. So it was clear I just wasn't being patient enough, but this did take a little while, at least 30 seconds. And so we'll see how quickly the 15.3 code does the exact same thing. And so this is what AS path prepending means, is I now have 1, 2, 3, 4, 5, because remember, I prepended to the original. And the original is going to be the one on the far right. Because remember, if these were all different, the last AS that it went through before arriving to me is on, I apologize, I'm actually backwards here. So we've prepended on here, right? So the first AS I come through is on the far right-hand side. That's the second AS, the third AS, the fourth AS, and that would be the autonomous system that was the last AS it went through before it got to me, right? So you read it from right to left if these were different numbers. Right now, that is the first AS it went through, and I've prepended, right, to the front 4 instances of my AS number. So now what we're going to do is we're going to put 5 instances of that AS number, and we're going to prepend it right here to the prefix that's being learned from Santa Rosa 01. So again, very straightforward. We'll jump to Santa Rosa 01 here, and we'll go into global config mode, and I'm going to say route map, and we'll call it the same thing, AS prepend 64555. Permit 10, because again we're just matching everything. So I'm going to say set AS path prepend, and what am I prepending? Well, we're going to do it 64555. We're going to do this what did I say, 5 times. So 64555, 64555, 64555. All right, so I've got it prepended on there 5 times. So we'll exit out. Let's go ahead and go into the router config mode for BGP. So router BGP 64555. I always like to do a do show run section BGP before I change anything. And in fact, let's take a quick time out here. If I do that same thing, do show run section BGP here, you're going to notice something, and that is that the med outbound statement is gone, right? Because I can only have one route map in each direction, right? So this is my outbound route map, my inbound route map. I had the med outbound. That is no longer here because we're now using the AS path prepend route map. So just a quick note there is that's where the med route map has gone. So here is our address family configuration for BGP AS 64555, and here is that original statement that we had. And I'm actually going to do something here. This is going to be in air, right? So I'm going to say route map 192.168.1.5. You'll notice that I'm only in the BGP router config section. I haven't gone into the address family because I want to make sure you see that this is what's going to happen when I say AS prepend 64555 outbound, and I hit enter. You can see that it gives you an error message telling you policy commands not allowed without an address family. And so this is one of the things that took a while to get used to when I first started playing with the address families, is I would jump right into router BGP 64555, immediately throw the neighbor statement down with the route map and try to drop it on there, and then you get this error message because remember, we're doing address families now. So I need to say address family IPv4 unicast, and then I can go ahead and put down the route map. Now I'm going to hit enter, and I'm going to scoot over to the ISP router as quick as I can here, and we should see that this is sort of refreshed much faster than it was with the 12.4 code. So I'm going to hit enter. We're going to jump over here to the ISP, and let's take a look and see. And I'm hoping that it wasn't one of those cases where it was just that the scheduler was running at the exact right time. But typically with the 15.3 code, it updated much faster every time I've run through this. And now, of course, since I'm recording, it's not cooperating, and it looks like it's going to take its sweet time here. So we'll give it a few seconds. And okay, great. And that was definitely quicker. I'm not sure how much quicker, but it was definitely quicker. So now when we take a look, we've prepended 2, 3, 4, 5 AS numbers. We've prepended our AS number, 5 instances of that. We've prepended it to the original autonomous system number here. And look what happened. Right away, BGP does the path selection algorithm. It looks at number 1 and says, what's the weight? It then makes its way down to number 4, where it says, what is the AS path length? And so, as you can see, we've had to prepend our AS number a number of times on the prefix, but we are very easily able to control the path selection. And so this can, like I said, this comes in very handy. It's a little more scalable and robust with respect to multi-vendor implementations, because the AS path is, again, it is a mandatory, well-known BGP attribute that must be supported. And the other two well-knowns are the origin and the next hop. And so this is pretty much it. We've actually now been able to influence the traffic and bring it back via router 2. However, what have we just done that we had talked about yesterday? Well, what we've created here is an asymmetric path. So I'm going to do we'll do a trace route from Santa Rosa 02. The local preference is telling me I want you to go out this way, right? But when it gets up here to the loopback on the ISP router, we've told the ISP router, because of our AS path prepending, hey, I now want you to come back that way, right? So again, asymmetric routing is not always a terrible thing. However, this is probably not how you want to have things set up. So let's adjust the route map. We're going to adjust the route map on Santa Rosa 01, router 6, and we're going to remove some of those prepend statements there. And so let me go back to, where are we at here? So do show route map. And I'm going to be interested in tweaking, let's see, I'm just going to see if it'll let me wipe the, so we'll say no route map AS prepend. And hopefully this is not going to 64555. And let me see if it'll let the sequence number go. Okay, so we'll get rid of sequence number 10. And let's say do show run section BGP. I want to make sure that it didn't, okay, good, so it's still there. So we're going to come back with a route map, AS prepend 64555. Did I spell prepend? I got that right. And we're going to say permit 10. And again, we're just going to simply set the AS path prepend. However, here, 64555, I'm just going to do it 64555. We'll do 2, and let's see what happens. So now I'll say do show run section BGP. I want to make sure that the prepend is on there, and then do show route map to make sure that our route map exists. And there's the statement there. And now we'll sneak back over here to the ISP router, and let's see if we have now, instead of using MED, let's see how long it takes the 15 code to update the NLRI, the network layer reachability information, which is a fancy way of saying the prefix or the route for the 172.16.0.0, and take a look at that, right? So the 15 code is definitely quicker. And again, this could be, I could be getting lucky every time and hitting it where the right, just right in the sweet spot for the scheduler. But having done this quite a bit, the 15 code definitely seems to make that scheduler update much quicker. All right, so we prepended 2 AS paths, and here they are, to what was the original AS path that ISP learned this prefix from. And take a look at what happened. We've been able to influence the inbound flow of traffic. And so this is really all there is to AS path prepending. Again, in a limited scale here, I'm actually going to go ahead and pull a 4th router in, and we're going to have 2 routers in my next tutorial. We're going to build on this, and I'm going to have 2 routers that are going to be AS200 and AS300, and they're going to be peering with each other, and they're going to be different service providers. So they'll be eBGP peers, and we'll see what it looks like, which may be in a larger organization or corporation, right? Because we are just, company A here. So if company A is a little larger, and let's say this is AT&T that they're peered with, what would it look like if they were to peer, if this wasn't here, and they were to peer out here, and let's say that this is, who knows, Verizon. right? So if this is Verizon out here, and then Verizon has router, and I think I've got router 5. So we'd use router 5, right, and say that this is ISP2. And we're going to do some AS path prepending, and they'll have an eBGP peering here, right? All right, well, that is AS path prepending in a nutshell. We were able to do a quick review of what the multi-exit discriminator config looked like in terms of how we were influencing the inbound traffic coming into our enterprise. Remember, when I say into our enterprise, we are company A, so this is kind of us right here, and this is how we're set up. And again, you can certainly do it with the MED. However, a little more robust way to do this is with AS path prepending, because again, AS path prepending is a mandatory, well-known BGP attribute, and what that means is it must be supported in all implementations of BGP software, so across all of the vendors. So you're going to find the AS path attribute on Junos, and in fact, I'm glad I mentioned that. I just remembered, with JunoS, if I'm not mistaken, the last time I configured BGP on JunoS, you cannot, I don't think you can even remove, there's one of the settings, I can't remember what it is, but I don't even think that you can have it not look at the AS path. It must look at the AS path. And I may or may not be totally accurate on that. Again, haven't used JunoS in a while. But it's a well-known mandatory attribute, and so it's got to be supported on all BGP implementations, which is why it's a little more versatile, a little more scalable, and a better, sort of a better best practice implementation approach than using the MED. Again, the MED will work. We saw that it worked. However, you may run into some inconsistencies because the MED is not mandatory and well-known. The MED is optional and it's non-transitive, okay? So I really appreciate you watching. I hope that this has added some value to your studies and your learning, and that's it. This is AS path prepending in a nutshell, and this is how you would use AS path prepending. So thank you for watching, and have a great evening.